Well, now I have time to do some videos. We're doing these videos on acids and bases, organic compounds, and solutions. This is the video on acids and bases. First of all, what they are. Acids are substances that produce hydrogen ions, or H+, when you dissolve them in water. Most of them contain hydrogen in them in some way, shape, or form, and when we dissolve them in water, these compounds dissociate. Dissociate means they separate. If you associate with somebody, that means you hang out with them. If you dissociate with them, that means you go your separate ways. When we take HCl, hydrogen chloride, and we put it in water, the hydrogen and the chlorine go their separate ways. They dissociate. You get H+, and you get Cl-. The H+ is what makes it an acid. These are some common acids. HCl is hydrochloric acid. This is stomach acid. H2SO4 is sulfuric acid. Sulfuric acid is battery acid. And CH3COOH, the one with the crazy looking formula, that's acetic acid. Acetic acid is basically vinegar. These are examples of acids. And again, most of them contain hydrogen in some way, shape, or form. That's what allows them to form the H+ when they dissolve in water. Because they all form the same ion, they all have a set of common properties. Acids tend to be sour to the taste. Think of lemon juice, think of vinegar. They tend to be thin or low viscosity substances. They feel like water. Again, think of vinegar. Feels like water. They turn litmus paper red. We'll talk a little bit more about that in a minute. They're corrosive. That means they eat other substances away. And they react with metals. The classic chemistry experiments that we show off in chemistry classes are the reaction between acids and metals. They produce hydrogen gas. These are all common to all acids. Now, the disclaimer, don't go tasting acids. Don't go tasting anything in a chemistry lab in particular. Acetic acid, vinegar, you've tasted that. You know what it tastes like, enough said. If you try to taste other things, they could kill you, so do not taste acids. Same thing with feeling them. Remember, they are corrosive. They eat holes in things, including you. You know what vinegar feels like, enough said. Don't go feeling hydrochloric acid. Don't go feeling sulfuric acid. It can cause severe burns. Bases are substances that produce hydroxide, OH-, when they are dissolved or dissociate in water. NaOH is a good example here. Again, that dissociation means going their separate ways. When we put NaOH, sodium hydroxide, in water, the sodium goes one way as Na+, the hydroxide goes the other as OH-, and that's what makes this a base. This is sodium hydroxide, commonly known as lye. It's used in a lot of drain openers, drain cleaners. It's used to make soap, like lye soap. Ammonia, a common cleaning agent, is also a base. Sodium bicarbonate, that's baking soda, that is also a base, but you'll notice there's no OH in these. They produce their OH in a different form, in a different way. This is what's called the Arrhenius definition of bases. It's the simpler definition. There's another definition called the Bronsted-Lowry definition of acids and bases. In those definitions, it tells us it doesn't have to dissolve in water to produce hydroxide. It can react with water to produce hydroxide. And that's what these do. You don't see OHs in them, but they still do produce OH when you put them in water. And again, because they produce that OH, they're all going to have a common set of properties. Pretty much the opposite of what the acids are. They're bitter to the taste. They feel like soap. They have a higher viscosity. They turn litmus paper blue. And again, we'll talk about that one in just a minute. Again, we don't want to run around tasting and feeling bases. Bases tend to irritate the skin, dehydrate the skin pretty badly. Can cause cracking, bleeding, that could of course lead to infections and other problems. So you don't want to run around feeling bases. If you have felt soap, you know what bases feel like. Enough said. Don't go run around feeling things like sodium hydroxide, because that will cause damage to your skin. Again, we don't want to run around and taste bases either. Some of us have tasted soap, whether we wanted to or not. We know what it tastes like as a result. Don't go around tasting soaps. In general, things that are bitter are poisonous, and that is no exception here. These are poisonous, so we do not want to taste them. The bitter taste buds are on the back of your tongue for a reason. You cannot swallow anything without it touching the back of your tongue. That's your body's way of detecting bitter substances, so we don't swallow these poisons, so we don't end up hurting ourselves. So do not run around tasting bases. Told you we talked a little bit more about litmus paper. Litmus paper is what we call an indicator. Indicators react one way with acids, they react a different way with bases. It allows us to identify acids and bases. Bases turn red litmus paper blue, acids turn blue litmus paper red. This is a strip of red litmus paper. You can see a drop of base has been put here, turns it blue. This is a strip of blue litmus paper. You see a drop of acid has been put here, it turns it red. You can go back and forth with these. If we wanted to turn this blue spot red again, we put an acid on it. If we want to turn the red spot blue again, we put a base on it. Go back and forth between the two. Base is blue, acid's red. We use litmus paper in tandem. We always try to use both pieces at the same time. That way we know what we're dealing with. If we have red litmus paper and we put something on it and it stays red, we really don't know what we have. It could be a neutral solution, one that's not an acid or base, or it could be acidic. We wouldn't know. That's why we'd have to have that blue litmus paper with us to see what happened to it. If the blue litmus paper stayed blue, we know it's neutral. But if the blue litmus paper turns red, we know we have an acid. So we use them together, we don't use them separately. pH scale, we need to know what the pH scale is and what it measures. pH tells us the strength of acids and bases. There's some bases, like I said, like vinegar that you can taste, that you can feel, and it's not going to hurt you unless you consume too much. Then you're talking about getting things like ulcers. There's certain bases that you can feel, that you can taste, and they'd be safe, like baking soda. But there's others that are obviously going to cause harm. So the pH scale gives us an indication of which ones are strong, which ones are weak. A pH of 7 is neutral, pure water is neutral. Below 7 is acidic. So 0 through 6.9, that is acidic. 0 being the strongest. Hydrochloric acid's down here at 0. Up around 7 is the weakest. Milk is somewhere around 6.5, so that's a very weak acid there. Some common things that we consume, lemons are about a 2. You know they're very sour. They're very sour because of the relatively low pH. Vinegar about a 2.9, again very sour because of that low pH. Apples, particularly your green ones, a little bit over 3. Tomatoes, 4. If you ever eat a lot of tomatoes and got ulcers in your mouth, now you know why. Tomatoes are acidic, and it's the acid that's eating away the lining of your mouth. It's that corrosiveness that gives you the ulcers. Above 7 is a base. Again, closer to 7 would be your weak base. Baking soda is about an 8.5. Toothpaste contains baking soda because it's a relatively weak base. Your soap, if you ever had that forcibly put in your mouth for saying things you shouldn't have, it's bitter because it's a base. It's 10 on the pH scale. Ammonia, common cleaning substance, 11.5 or so. Drain cleaner like Drano, that's that sodium hydroxide again, up at a 14. Very dangerous stuff because of that very high pH. Again, 7 neutral, below 7 is acidic, above 7 is a base, and note the colors they put here. Red for our acids because that's the color they turn litmus paper. Blue for our bases because that, again, is the color that they turn litmus paper. Last thing I need to talk about is neutralization. When you mix an acid and base together, they neutralize each other. They cancel each other out. The hydrogen from the acid, the hydroxide from the base, those two ions that they produce, combine together to make water, a neutral substance. The leftover ions combine together to make an ionic compound that we refer to as a salt. This one is table salt, sodium chloride. So when we're done with this reaction, there's no acid or base left. This is what's called a neutralization. Because there's no acid or base left, we say that they cancel each other out or neutralize each other. Once again, if you have any questions, post them on the wall or ask me in class.